Hello, this is Victoria Baltasar, and I'm going to present a middle school grade 8 lesson on atmospheric air pressure. So the NGSS state standards is the MSESS2, that's 5. Collect data to provide evidence for how the motions and complex interactions of air masses result in changes in weather conditions, with an emphasis on how air masses flow from regions of high pressure to low pressure. While the CCSS standard on ELA literacy RST 6-8.4 is determining the meaning of symbols, key terms, and other domain-specific words and phrases as they are used in a specific scientific or technical context relevant to grade 6 to 8 texts and topics. Big ideas. Changes in weather systems are brought about by the effect of altitude with the atmospheric air pressure and air masses. So the following are the essential questions. What are the categories of air masses meteorologists identify according to where they form over the Earth? Describe the effect of altitude in low pressure system and the high pressure system in the atmosphere in the Earth system. And how does unstable pressure in air masses produce storms? So our do now, students, I'm giving you a KWL chart. So fill out the first two columns in the KWL chart, then we're gonna be watching a video on air mass. So first, on the K, what do I know about air mass, effects of altitude with the atmospheric air pressure, and changes in weather? And for W, what do I want to know about air mass, effects of altitude with the atmospheric air pressure, and changes in weather? So we're just going to fill out the first two columns. At first, how do you want to describe anything about air mass and the effects of altitude, the heights, the mountains, the summits, what they know about the pressures where they are in the when an airplane is above the sky, so and the changes in weather, and also what do you want to know. So with that, let's while you're filling out your KWL, let's watch this video on air masses.
Air masses. Objective: to learn the four types of air masses. An air mass is a huge body of air, so large that it often stretches for several thousand miles. Air masses generally have similar temperature and moisture properties throughout. The geographical location from which an air mass originates is its source. The types of air masses formed on Earth are determined by their source region. Air masses can have one of four qualities: continental, maritime, tropical, or polar. Continental air masses occur over large land masses and usually contain less moisture than other air masses, meaning they tend to be dry. Maritime air masses originate over a large body of water and are also known as oceanic air masses. Because they form over water, they are moist. Tropical air masses form in regions of lower latitudes and are usually warm. Polar air masses form over polar ice caps and are very cold. As these air masses move across Earth's surface, they will change, becoming modified according to the characteristics of the location beneath them. For example, an Arctic air mass with very cold and dry air moving across the ocean will become warm and moist, changing over to a moist maritime polar air mass. When this polar air mass moves south from Canada into the southern United States, it will acquire warmth from the ground below and become drier due to a lack of moisture. This air mass has now become a continental polar air mass. When air masses stay long over a region, they control the weather of those regions.
And over continents like this, we find air masses that are relatively dry. Several major air masses affect our weather in the United States. Maritime tropical air masses, forming over the oceans near the equator, are warm with a great deal of moisture. During the summer, these air masses usually result in rain. But in the colder months, the precipitation could be snow.
In the northern Pacific Ocean and in the North Atlantic, we sometimes find maritime polar air masses. During the summer, these air masses in the Pacific usually mean fog along the west coast. In the east, they often result in cooler temperatures. But in the winter, these polar masses from the oceans can produce heavy snow and sometimes even blizzards. To the south, continental tropical air masses form over Mexico during the summer, bringing hot, dry air to many states in the United States Southwest. Finally, continental polar air masses form over northern Canada, resulting in very cold winter temperatures in parts of the northern United States.
Summary. Air masses are huge bodies of air, often extending for several thousand miles. Air masses are characterized by uniform temperature and humidity. Air masses can have one of four qualities: continental, maritime, tropical, or polar. As the air mass moves, these qualities can combine to produce the type of air mass, such as a maritime polar air mass or a continental polar air mass.
Okay then, so thank you very much to AccuTeach.com. So with that, we proceed to our KWL chart. So by now, I hope you are done with your first two columns, the K column and the W column. So now, class, we will be presenting a PowerPoint here, and with your small groups that you have formed, we have formed the heterogeneous small groups. So you're gonna brainstorm and enter in your science journal your notes as you brainstorm and prepare for a group presentation. And that will be on the effect of altitude and the atmospheric air pressure and the air mass and the changes in weather. Okay, so let's have this. So the atmospheric air pressure, so thank you to Pearson Education Incorporated. So we have here the low are represented by the L on red, while the high pressure is represented by the H in blue. So pressure is defined as a force per unit area, and it comes in different units. So PA is pascals, MB is millibars, HG is in mercury, while PSI means pounds per square inch. And the pressure exists due to molecular collisions. So pressure increases with higher density and higher temperature. So pressure anywhere in the atmosphere is due to the weight of the air above. So if you would locate the P1, which is in the low surface area, the pressure, so there is a dash line here, a hidden line, dash line there that separates the area that affects the surface which affects the pressure on the low lying areas. So the that dash line separates the pressure affecting the low level areas, and that is only on P1. So below that dash line is only affecting the low level areas, but it does not affect the pressure at the summit of Mount Burt. while the top of the dashed line affects the pressure both on the summit of the mountain and the pressure on the low level area. While pressure decreases faster near the surface, less so aloft due to higher density near surface. So the pressure gradient force, or PGF, always points from high pressure toward the low pressure. So the movement is from high to going to the low, okay? And pressure is viewed horizontally using isobars. So isobars are lines of constant pressure. So as we have noted earlier that the movement is from high to low. So as you can see, the arrow is pointing going to the low pressure. So if station pressures were used, so the low this the in the map of the USA, so our location in the USA, so low pressure in mountain areas are in L, while high pressure in coastal areas. Because coastal are lower in altitude, while there is a low pressure in the summit in the mountains, there is a high pressure in coastal areas or the low level areas. But this is not a true picture of atmospheric effects. Okay. So on the sea level pressure, or SLPs, the surface pressure observations are reduced to sea level, or 10 millibars, which is over 100 meters, is typical in lower atmosphere. The sea level pressure values are the numbers on sea level pressures maps. So surface pressure observations are reduced to sea level. The sea level pressure values are the numbers on sea level pressures maps, and effects of elevation are removed, revealing a more useful horizontal pressure distribution. So why do we care? The SLP, or the sea level pressure, an important weather analysis tool, because the cyclones are due to the low pressure centers, while the anticyclones are due to the high pressure centers, and it also has the troughs and the ridges. So all of the above associated with various weather, such that the cyclone, these are the pressures that are on the low, in the at low pressure during the cyclone, and these are the high pressures on the anticyclone. While the ridge is a bow of in isobar indicating a line of high pressure, and a throw, a bow in isobars indicating a line of low pressure. So with that, we have this map. This one is more accurate on the low pressures and the high pressures, uh, indicating the pressures on this map.